Hello. So today we will study about AC position servo system. You know what do you mean by a servo system? What is a servo system is? That is your output potentiometer will try to follow your reference potentiometer in a smooth fashion based on a closed loop control system. Now we are going to study about AC position servo system. AC position in the sense we are going to use an AC machine here. Now the objective here is, if you look at the study setup here, we are going to change this reference potentiometer and the output potentiometer which is connected to the AC motor will follow your reference potentiometer. Now where is this AC potentiometer connected is, this is where you have the differential potentiometer, they are connected. There are two resistors connected in parallel to a common source. This is a common AC excitation. And where are you getting this AC excitation is from this particular power on. When you switch on this particular power from the AC power supply, you have power available at both these particular points. Now you are having two potentiometers which can be moved with a pointer. Now this reference potentiometer that you are having here is directly connected to this knob here, this potentiometer knob. As I change, what happens is you are moving your pointer up and down. What exactly happens here? As you move, right, you are moving the pointer, so a differential voltage will be generated across this particular point, the first line. Now similarly, now if you, I am just switching on everything here, and then you see here the objective. When you rotate, your output potentiometer will also follow. This is what our final objective is. Now before that, I am switching off both the things. I will come back and tell you what is the need for these two switches. Now let us keep somewhere at 90 degree reference potentiometer. When you keep it as 90, it means that, see, total 360, right? If you can keep it at 180, it will be almost halfway of your pointer. So which means out of the total voltage, half the voltage is available across one end. Now what is the voltage across this output potentiometer? This is not at all moving, right? There is no voltage here at all, right? Initially it is a zero voltage. So a zero voltage will be here. So VE that you see here, this is an error voltage. What is error voltage? The difference in these two voltages is what is your error voltages. Now you have some voltage across reference potentiometer point and you have zero voltage across your potentiometer point. Now this is fed into an instrumentation amplifier. Normally these instrumentation amplifier inside this particular setup, they are built using three operational amplifier. You know the characteristics of an operational amplifier. It will have a high gain, it will have a zero output resistance, high input resistance, large bandwidth, all those things. But all we are concerned at this particular point is we are concerned only about the gain of the amplifier. To start your experiment, always keep the gain to a maximum position here. Now the power is available only till this particular point. You are getting an amplified signal. You can use a multimeter and find out what is the voltage across these points. Now when you switch on S1, what happens is the power, whatever it is from the output of your instrumentation amplifier, is fed to a power amplifier. Now what is the characteristics of this power amplifier? This power amplifier is normally a class AB amplifier, a class AB push-pull amplifier, and its output rating of this power amplifier is 40 watts DC supply, 40 volt DC supply and 5 watts output power. Why do we call this as a power amplifier? Because these amplifiers are the one which is going to drive your AC motor. So if you look, again the output is off because we have not switched on this switch. So from instrumentation amplifier, since we closed this switch S1, the power is available across your input of your power amplifier and your power amplifier's output is available here, but it is still not fed into the control windings of your AC motor. Now I switch on this AC servo motor. Now look at the potentiometer also. Once I switch on this AC servo motor, what happens is current will start flowing into your control winding and there will be a flux that will be generated. Will the motor will start rotate? It will not rotate. It is rotating because you need two fluxes for your motor to revolve. One is your control winding flux and other is your reference winding flux. So these two will be 90 degree difference with each other mechanically as well as electrically also. Mechanically also they are placed at 90-degree difference positions, and electrically also there is a 90-degree phase shift between these two fluxes. Minimum of 30-degree of phase difference is required for any motor to rotate, and you need two different fluxes to operate. So here we are having two different fluxes. Now how is it working? Now when there is a power that is flowing here, please note that there is an error voltage that is flowing here. So which means that initially we have assumed that there is a maximum error. When there is a maximum error, maximum flux will be there and maximum rotation of your AC servo motor will happen. And where is the shaft of your AC servo motor coupled? It is coupled to this reference potentiometer. Just imagine I am switching it off. Right? When I am switching it off, please, now I have kept it at 30 position. Right? Now whatever is the voltage that is available here, there is zero voltage across your output potentiometer because this is not moving, and there is a maximum error voltage here, there is maximum power amplifier output is available across this particular flux. But still we have not switched on this control winding. Now when I switch on this, your AC servo motor has to rotate for over a long distance, right? So when I switch on this, look at that particular pointer. It moves over a larger distance. And every time it moves from one position to the other position, there is a voltage that is fed here. I mean, this potentiometer is connected to the knob over here. As it moves, what happens is this pointer moves upwards or however it is, and then the error voltage it takes place simultaneously. When I move now, you see here it is rotating. Now what is done is the error voltage is calculating amplifier, the power is again fed back, and then the flux is changed, and once the output potentiometer also reaches the reference potentiometer point, what will happen? Both are at the same position now. This voltage and this voltages are same. So there is no error voltage. So the output of your amplifier is also zero. So the power output amplifier is also zero, and there is no flux that is being fed to this control winding, and there is only one flux that is from the reference winding here, which will not make your AC servo motor to rotate. Now if I slowly move, then there is a small error here which is compensated and your output potentiometer moves. So this is what is about the working. What is your observation? What is your observation here is, keep it initially at 0. Keep it initially at 0. Now let it come back to the original position. It is still calculating. It is the difference voltage is still calculating, fed back, and then the power is calculating. Once it reaches 0, then your observation must start. Now it is both are at 0 position. Now move it to 30. Find out the exact location of this. Move it 60. Again find out the exact location. There will always be a small difference. Why? And why that small difference that is taking place is because there will be some fringe fluxes that gets lost, right? Some energy will get lost because when you are feeding it to a control winding, and there are a lot of input resistances inside this amplifier and inside this power amplifier also, there will be small amount of power that is lost. So that difference is created into a flux, and then that is driving your AC servo motor. So there will always be a small difference. So that is what you need to note. Move to 90, move to 120, move to 150. Likewise, you complete the cycle. Right? So this is the complete procedure for this particular experiment, and this is a very simple experiment.